When you're ready, I will talk. You can
Yes.
say. Okay, you can tell me.
Yes.
Yeah, I will introduce. We have 6 members. We're gonna talk according to the name order. I will introduce this.
Okay. 1 second. It's
Oh,
already.
this is group 12 and part of group 2. Those are our team members. We have 6 team members, and we will talk the slides according to our name order. So let's look at the slide 18. Okay, we talk about the application side. So for the classification, we can use a lot of applications. First of all, is a real-time prediction. Naive Bayes is an eager learning classifier, and it's sure it's fast. And then the second one is multi-class prediction. This algorithm is also well known for multi-class prediction feature. The third application is recommendation system. I think this is really hot recently and use the naive Bayes classifier. Okay, let's look at next slide. So these slides we're talking about definition of text classification training. For example, we will have a document space of X. Actually, we can see we have all the real documents. It's actually represents high dimensional space. And then we use C to represent our fixed set of classes. And then the class are normally human defined. For example, human can define the larger of data as spam or not spam. And also we need the training set. And the last one, we have to like using a learning method or learning algorithm, then we will to learn the classifier. Why that maps document to the classes, which is the method you say y as an object and x as a document space and point to the classes C.
Hello everyone, this is Rohit. So based on the previous slides, I have a question. The question is, what are the requirements to map documents to classes? And the answer is arrays and subcollections. In the next slide, we look at the definition of a TC. This is application and the testing slide. So here we have a description D, which is a subset of X, and this belongs to a document. To determine, we have y of D, which belongs to C, that is the class which is most appropriate for D. We will look at the next slide now.
So, hi, this is Nivedita. Some of the examples of how the search engines can use classification is being described here. One such example is language identification, where the classes can be split as like English, French, etc. The other example is sentiment detection, where reviews are written based on a product or a movie, and based on those reviews, whether it is a positive comment or a negative comment. And the third example is the automatic detection of the spam pages, whether those pages are spam or non spam. And one last example is the topic specific or the vertical search. Vertical search is the search that is restricted to a vertical, like a particular topic related to health, etc. So, whether it is a relevant one to vertical or not. So my question is here, which is better to evaluate the customer opinion of a product, topic specific search or sentiment detection? I guess the sentiment detection would work because based on the reviews used by the people, those who have already bought or have had a experience watching the movie, the positive and the negative comments might be helpful in deciding the customer opinion.
Hi, my name is Manjusha. I'll be talking about evaluating classification model. So for evaluating a classification model, we want the evaluation to be done on the test data that are independent of the training data. And we'll also want the training and the test sets to be disjoint, which is mutually, we want them to be mutually exclusive. And we have a few metrics that will make us understand how our classification model performs on when it is applied on a test or a training data set. So a few of the measures are accuracy, precision, and F1. Accuracy is defined as a fraction of instances that are correctly classified, and precision is the fraction of correct predictions for a class, and recall is the fraction of instances of a class that were correctly predicted. So and F1 is also a measure that will affect the evaluation, which is harmonic mean of precision and recall. Nivedita, can you go to next
Yes.
slide? Yeah, the above one.
Okay.
So we have the measures, other measures such as true positive, false positive, true negative, and false negative. We get the precision by dividing the true positive with the sum of true positive and false positive. These are the techniques that we use to measure evaluation. So my question is, when evaluating test data, should the test data be independent or dependent on the training data? And the answer is it has to be independent of the training data. Yeah, that's it.
Hi, this is Vashita, and with both precision and recall parameters, we can find the combined measure, which is F1 measure, and F1 allows us to trade off precision against recall, and the formula is F1 equals to 2PR by P plus R, and this F1 measure is called the harmonic mean of both precision and recall. Which we have a formula 1 by f equals to half into 1 by p plus 1 by r. And my question is, the next slide, please. What type of score is harmonic mean of precision and recall? And the answer would be F1 measure. Thank you.